is going to hurt your ears because I didn't realise that the microphone was on the floor. Just give me a second to move it. Hopefully you can all hear me alright. OBS says you can. I'm presuming you guys can. If you can let me know if it's too noisy, just give us a shout. It should be alright. It's a bit grainy, I think, but I think it's alright now. But if you let us know, if it's alright, then hopefully we can just carry on. And yeah, we'll get cracking. Look, 8 people. I mean, I knew I was going to pop off this year, but oh my god, this is insane. 8 people watching. Right, cool. So it's a little bit like my internet's not very good. Like we might be in the 21st century, but my internet is a bit bad because I'm in the loft, so it's not very good. But it's what it is. So yeah, so hopefully you can see what's on the screen. It's going to be a little bit zoomed in at the minute. I need to get rid of this bloody second chat thing. It's really annoying. Whatever. No, you can see that alright, can't you? That's not too bad. I thought it'd be worse. Because I've zoomed in quite a lot. So, I've got paper 2 tomorrow, 1 o'clock. Obviously I'll be there outside the exam. Of course you're going to pass. Of course you're going to pass. So, they can ask you a lot of stuff. So I thought I'm not going to go through a full paper. We do not have time to go through a full paper. I've only got about an hour and a half, really. Sorry about that. I can't, as much as it'd be great for me to stream all night, I'm not doing that. I don't like you enough. But yeah. So obviously speak about your computational thinking. So you've got the need for abstraction. So remember as well that you don't just talk about graphics for every single question. You guys are all, or no, maybe it's just a kid thing, are really good for just putting, get rid of the graphics. Just think about something related to the scenario for abstraction that you can go, alright, we'll remove this detail, we'll remove this, we'll replace these with symbols, we'll replace these with whatever it is. That then you've got your thinking ahead, so identifying any inputs and outputs. Think about preconditions, so it might be an algorithm. So I think they say, one of the questions I've seen for this one is precondition for binary search, which obviously the array has to be sorted, that kind of thing. Benefits and drawbacks of caching, so saving some information. Later you've got web browser caching, web caching, that kind of thing. So obviously go check that out. Reusable program components, that's your functions and procedures, why are they good. Then being able to look at a problem, identify what functions you might need. Like I said, you're not going to get loads of questions on these, but you will get them. You've got your logical conditions, like decisions like if statements affecting the flow of your program, and then concurrent processing, pipelining, those kind of things. Those are different. If you remember in the revision folder, there's a separate thing all about concurrent processing, so you can go look at that. Then we've got 2.2, so need to know what sequences, so making sure your program code is in the correct order. Then we've got iteration, which is your loops, and branching is your selection. Recursion, so that's when a function calls itself, what the benefits of that. It uses more memory and things, so that's not a benefit, but it looks nicer to read is a benefit, that kind of thing. You've got a difference between a local and a global variable. So a local variable only exists in the scope it's created, so in an if statement, in a function. Global, it's used throughout the program. Modularity, functions and procedures, priority passing by value by reference. So hopefully you remember that by reference is a pointer to the original, whereas value creates a copy. And a modular program has functions, procedures and parameters are the variables that a procedure or function requires to work. IDE features, so to develop and debug. So developing your developer tools is going to be like your pretty printing, and your text editor and all those bits, and then debugging would be like your breakpoints, your stack trace, variable watch, that kind of thing. Again, we've got a separate lesson on that. I'm not going to sit and go for the whole thing. Then you've got your object-oriented techniques. Those are so important. It's pretty much every single exam. I mean, you've already done half of it, and you already got a question on OOP already. So you're pretty much guaranteed to get one in paper 2 as well. I'd be very, very shocked if you didn't. So just remember to do that. So I think we'll probably focus on that a little bit later on. And then look at problem recognition, to identify the problems of a program. What is the actual thing you're trying to solve? Obviously, you've done this in your NEAs. Decomposition, divide and conquer, abstraction, and then backtracking, data mining, heuristics, performance modeling, pipelining, and visualization to solve problems, which we did very, very, very recently. So again, that's all should be in Teams for you. And then the very last part is looking and designing algorithms. That's you actually writing an algorithm for whatever reason. You don't want to be leaving these blank. There usually a lot of marks. You've got the suitability of different algorithms for a given task and data set in terms of execution time and space. So that is your big O notation stuff. Again, there's a guide on there in Teams that you can go grab, talking about the difference between like space and efficiency and things. So there's a cheat sheet I think in Teams as well. I'll happily, if you want to go check that for me and let me know if it's there or not. If not, I'll get you it. Don't worry. Obviously you can't take it to the exam, but then knowing all your big O notation stuff, being able to compare complexity of algorithms, and then obviously knowing you're going to get a question on. There's pretty much trees are on every single exam. You've even got a tree in paper 1. That's not an indicator to say what you're going to get tomorrow, but you need to know stacks, queues, trees, linked lists, depth first, and breadth first traversal. Now it's just post order, so don't worry about in order because it's pointless. They're going to ask that anyway. It's pointless. And the other one, and then you've got obviously bubble sort, insertion sort, merge sort, quick sort, Dijkstra's, A star, binary, and linear search. So give me a second because I have messed up the stream already. Because I am I can't stream my tablet. It's really annoying. So what I've got to do is I've got to video call myself on Teams. And when I video call myself on Teams, that allows me to stream my tablet. It's like possibly the best thing you've ever seen in your life. So just bear with me. Just turn it down as well. You don't want to hear me calling myself. There we go. Bear with me. It's going to be awful on the ears. Give it a minute. It takes a while. You are going to hear the Teams sound over and over again, unfortunately. I don't know why the volume won't go off. So I'll tell you what I'll do. I'll just turn my audio Alright, so I seem to be having some technical issues, which is great. So what I'll do is I will replace the screen with this one, and I'd like you to, fingers crossed you can see it properly. You've got 4 minutes just whilst I try and fix this Teams issue. And so main features of a tree and what makes a tree a binary search tree. Very common question. Have I got that? You can either type it in the comments or, oh no, I don't really care. Do what you want. Well, it looks like it's not going to be as good as the last one where I got to live edit the paper. So looks like we'll just have to be boring and just talk. So apologies for that, guys, but not much you can do. So look at this first question then. Obviously I can't write on it, so I'm just going to talk. So main feature of a tree. It is a data structure. You can talk about that. Should I do it like this? Will this be better? I'm not sure. Let's run a bit of code on there. There we go. So consists of nodes. I'm not sure you can see this, so I'll just make sure you can see it properly. Just bear with me. Alright, Jacob, calm down. So hopefully you can see this anyway. So it consists of nodes. Nodes can have children, or subnodes is probably the better word for that. Connected by branches. First node is root. It would be sort of like somewhat quite logical. I'm not sure you can necessarily see that. So I'll just try and figure out the best place to put it. But it's not a big deal. I can just do that, which I think is better. So you should be able to see that now. I'll just do this so you can, hopefully, that should be fine. It's not a bad idea, James. I could use Discord, but I don't have it on my tablet, so major Seebs. Plus, we're running out of time. Just me messing around. So hopefully you can see that better. Okay, so we'll just do that. Next one. What makes it a binary tree? Well, you can only have two nodes connected to one node. I suppose two subnodes would make more sense. So two subnodes, and then I suppose it's one mark, but you can describe it as well. So you could say, you know, if node less than parent, go left, else right. Something like that would probably make a lot of sense. So that's for that one. So then we've got this lovely tree, which obviously is very similar, this one, to what you had in your real exam. We've got to add in, so we've got brown here, so B comes before G, R comes after, obviously they're both B, so R comes after L, and then so I guess it'll be down there, and then obviously your white, greater than, and then your orange, and so on. I don't think that's anything that anybody needs me to go over. I can't draw on the screen, so I can't really draw it. But you'd have like brown would go here, you'd have white there, orange there, purple there, like that. And then you've got this binary search tree here. How would you do a depth first post order traversal? So that is your left, right, root. Done the left there, right, root. Done the left now, so we go to the right. So you'd have 5, 31, 20, 48, 45. Then you wouldn't have 50 yet. You then go to here and do left, which is the 60. Then you'd go all the way down and do left, which doesn't exist. Right, root, 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 root. So you'd have 5, 31, 20. So 5, 31, 20, 48, 45, 60, 92, 88. Then you'd have 98, 76, and 50. Because post order depth first is left, right, root. I don't know if that makes sense for you all. Obviously I can see the chat, but I just don't see it as I'm doing stuff. Don't really like a Discord plugin for that, so yeah. I probably could do something better than what I'm doing, but oh well. So that's that one. And then for this one as well, you have to explain it, so you would just explain what you've done. So I've just brought the mark scheme up. Just make sure you say go left, go right, go root. Keep repeating until you've visited everything. And then breadth first, if you remember, you start from the top, and then literally you go in row by row. So you're doing 50, 45, 76, 20, 48, 60, 98, 5, 31, 88, and then 92 last. So you visit the route, and you visit all the things since that route, and then visit all the subnodes of the first node, and so on. But essentially, row by row. Which is those two. I mean, if you get those two questions, that is amazing. That would be like the best situation. But with them already giving you a tree question, it means nothing. It genuinely, what I say right now does not mean a thing. They could still do it. A tree is a perfectly valid thing for them to go over. So what we've got next, we've got binary search tree values is stored as an array of nodes. Each node has a left, a right, and the data. The following data is entered below. So we've got 68, 30, 73, 22, 1, 90, and 70. What is the purpose? Oh, sorry, complete the remaining left and right pointers. So you got to fill in that table and figure out. So basically, it's asking you to do this job here. I'm guessing. Yeah, they've put this data in for you. So they want you to, essentially, I think the best way to do this question, I'm completely honest with you, would be to draw it out, like here, as a binary search tree. Obviously 68 would be the root, so what would come left? Well, 30 would come to the left of it, wouldn't it? So your 30 would go here, because obviously it's the left and right of it. 1 would 30, and 2 would be the 73, because 73 is bigger than 68, and 30 is smaller, so that's already done for you. So what would come next, what would come next, what would come next, and so on. So I would draw it if I was doing this question. I would literally draw it here first, and then just fill in this table. Relatively easy to do. Then answer the question: what's the purpose of free pointer? Well, free pointer just shows you where the next element's going to be put. So you've got 6 here. Was the last one? That's 7. So 7's going to go there. Pretty easy, I think. The following data is added. Update the new nodes. So you'd have to obviously just add that as you would normally, using your left to right rules, and then make sure you update this table accordingly. For that one there. Does that, are you all happy with that so far? I'll stop for a second. Sound right. Cool. So then we've got obviously a nice little graph. We've done this question before, so I'm not going to sit and draw all over it. So what is this? Hopefully you know that this is a graph, and it is weighted because we've got those numbers on the lines, on those edges. So then what? State what the heuristic values could represent. Anything. But there's no guidance on the mark scheme for this one. But you know, it could be distance. Probably more likely. I wouldn't say it was time. It seems a bit weird. You wouldn't say it's going to take 233 minutes or seconds. So it's probably distance of some sort. What is the purpose? So it's a rule of thumb or a best guess to speed it up. You need to remember that the A-star algorithm is just Dijkstra's. It's just a sped up version. So where Dijkstra's, you're expected to calculate every single route, and then you work out the quickest one for that, which makes the most sense. Obviously, you're going to know exactly what the fastest route is if you visit every route and time yourself. You know, if you're going to town, you can take every single possible route and work out which one's the quickest, and then always use that route. That makes a lot of sense. Where it doesn't make a lot of sense is when it's time sensitive, when things change, and that kind of thing, or in like a game where it needs to be done quickly. So that's where the A-star algorithm is an improvement, which isn't perfect, but it uses these heuristics to have a guess and presume what you're going to do. So you need to perform the A-star. So all you're doing is you're starting from this. It says go from H and E, so we go from here to here. So you're going to look there, and you're going to say, right, what's the quickest route? So you look at H and go, right, I'm going to go to G first. So then you calculate G. You go to fill in the grid. I think they give you a grid on this one. They haven't given you a grid on this one. So just so you remember, you should have node, then you should have distance. That's your total distance travelled so far. Then you've got your heuristic. Then you've got D plus H, and then you have, so that's distance plus heuristic, and then you've got previous. That's what you should be doing, roughly. Hopefully you can see that okay. That's what you should roughly be doing for your table. And then all you're doing is you're picking that quickest route. So you go 25 plus 70 would be 95 coming from H. Then you do N, because obviously what you do as well is you don't just go to the quickest one. You don't just go, all right, well that's 25, so I'm going to go there, because that's not technically going to always be right. Like this could look really good, and then this, we've got a 370, so that might not be the quickest route. I think it is, looking at it, and even if you're struggling, if you're really struggling and you don't know what to do, and it's a lot of marks, it's like 8 marks, you can still get a mark for just getting the right path. So just look at it and go, all right, well, do a bit of maths, right? H 25, 51, 307 plus 50 plus 70 plus 80, right? That's smaller than either ones, so I'll put H G L E. That's absolutely fine. They'll get you a mark. That's better than leaving it blank. But if in your table, you put H 0, 80, 80, so obviously the distance is 0, 80 distance plus heuristic would be 18, no previous node, you would get a mark for that. You then get a mark for visiting anything that connects to it. So what you want to do is you want to visit a node, then you visit all the neighbours. So you get H, you look at G, you look at N. Once you have done that, once you've looked at all the neighbours, you can tick that off. You say, right, so in your little thing, say you was filling this in, you say H, and then you put like a tick or something to say you visited it once you've got to that point. They aren't going to know when you've ticked it, but that's what you do in the algorithm. So you tick it off and say, right, that's done. And then you say, right, then once you've done that, you've done G, you've done N, what you're going to do is you're going to visit the shortest one's neighbours. So at that point, you're going to make 95 and then 90 plus 210. So it doesn't make sense to go to this one. So you go here, you're going to visit L, you're going to visit M, because they're the shortest ones. Same process again. Visit E from L and M from E. And then, that's it. Obviously you would have to make sure as well that, just make sure you have visited. What you don't want to do is, I think it's a different question to this one, where you visit all these ones and then you've still got this one here because N hasn't been visited yet. But look at a mark scheme. I'll just pull this one up now. So you get a mark for visiting H with the correct heuristic. So that's a given. It's always going to be distance travelled 0 and plus whatever this is, like for the heuristic. So in this case 80. So you get a mark for that. Then visiting both the neighbours, so G and N from H, calculating it correctly. That gives you a second mark. Then going to the next one. So saying, right, G is the shortest, and then visiting L and visiting N, that's another 2 marks. And then if you stop there and go, right, I'm confused, I don't know anymore, that's 1, 2, 3, 4 marks, then write down the final path, that's 5 out of 8 marks. That's really good, without even really understanding what to do. So, as confused as that might be, definitely practice and, go over the answers and try and get full marks, but if you're struggling, that's what you should do. And we've got what's the decision. So that's just choosing. The decision is which node to take next. That's literally it. And describe the effect of this decision. Well, then you ignore the next one. What is it? I don't know how you say that really. So your decision is definitely going to be choosing the shortest distance, and then all the nodes following that path are taken. Makes sense. Next one, concurrent processing. So this one I'll get Notepad back out. So concurrency. So remember, pipelining is not concurrency. All right. Pipelining is overlapping the FDE cycle. So you fetch something, then whilst you're decoding that one, you fetch something else. Whilst the first one's being executed, the second one's being decoded, you then fetch the next one. All right. You can't do that if you're branching. Concurrency is completely different. That is where you're doing more than one thing. So more than one thing at a time. Okay. This requires multiple CPUs or a multi-core processor. Each processor works on its own. So what you don't say is, oh, it's where two processors team up and work on the same thing together. They can't do that. You can't have two things fetching, decoding, and executing together. That's not how it works. Those who have done a bit of C# and things, you could talk about in this one as well, like multi-threading. Multi-threading, that is where essentially at the start of a program you essentially split. So you got like your, I'm going to draw this out, but so you basically like branch off your program and have like a function running in one thread, a function running in another thread. So instead of running this, then this, and this, the program basically branches off and uses your cores to run things at once, which is useful. You can't do it in like JavaScript or anything like that, but you can do it in C#. What's that? C# multi-threading. So I can find an example for you. So here you can say, thread T equals new thread. You see, what that's going to do there is that's going to do that whilst the rest of the program's running. You can either wait for it to finish, or it might just, let's say it had like an alert in this, it just run that halfway through, like you just appear, something like that. I don't think I've got C#. I'll get rid of this. I don't think I've got a thingy. Let's just try something. I'm just going to copy this code in just to show you it working if I can. One sec. I'll see if I can do it also thingy. I'll carry on, but I'm just going to see if I can install something for you to show you. But I haven't programmed C# in ages. But it's good. So yep. So that's like your basic knowledge. If I put my notepad back up. So then each processor or thread or whatever can do its own thing. Okay. So there's loads of things. It's talking about for searching. So you could potentially have two searching algorithms at the same time. So for this particular question, so multiple, I'll put algorithms, but I'm all about searching at the same time, because we're using multi-threading. So you might have thread 1 is binary search, thread 2's bubble sort, and you get a message box.show that or alert that pops up saying right done, and you say use racing 3 program or something. Or it might be to speed up, like to speed up a linear search. If you imagine you've got this is my list of numbers, right? I'm trying to look for this one here. Well, instead of searching from the start, why don't I have 2 threads? One starts, so thread A starts there, and thread B starts there, and heads that way. See what I mean? Like, so A would go that way, and it sort of meet in the middle. Like if he's looking, like if you wanted 2 people, so like 2 teachers looking for a student, you're not going to both go together. One starts at the back, one starts at the front. Do you know what I mean? Or A star. If you say right, one takes one route, one takes the other route, and finds the best way. There's a lot of things like that. You can talk about, so you can potentially find something quicker. So we say Y. It's faster, but a lot more RAM used. Inefficient for sure. I can't spell inefficient. But obviously at the cost of, as well, using multiple search algorithms. Is that efficient? How important is this data? That kind of thing. Hopefully that's made a bit of sense. I wonder if this program is actually gonna. It says it's installed, so let's have a little. Should see if it works. No, that's not working. I don't think it's as worth the effort I'm putting into it. So whilst I try and make life better, is that alright for everybody? Oh, so we try to get that working for you. I should just use replit. It would be a lot easier to do a C# replit. I'll look into it when I can be bothered. Yeah, so your next one. So 2 features of the problem make it solvable computation methods. You did this. You did this. You did this. You did this. For your coursework. This was your NEA. Like the first part, your analysis or whatever. You have to talk about how your problem was solved by computational methods. So Dexter is leading the programming team for simulating an A&E room to train hospital staff. What features make it solvable? Anything you can think of. It will have input, process, output. It will have decisions like logical reasoning. It will have maths. There's loads of things. So then, decomposition abstraction. 9 marks, seems like a lot. We know what these things are. So, if we go for decomp, we're splitting up the problem. Once it's split up, it should be solvable. These solvable parts should become subroutines. So like if you've decomposed it, right, so it's the I don't know, the queue checker, that's a function queue checker, and you can start it. That is divide and conquer. rather than trying to do the whole thing. And then yeah, that's about it really. Then you've got your abstraction, removing unnecessary bits. You guys are good at this. I can't spell unnecessary apparently. You know, and with some examples, so you might you don't have to in the simulation. You're not going to have people in there. You're not going to have the design or the location or the layout of the hospital. It's irrelevant, that kind of thing. So you're already looking at the things that need to be done. So that'd be AO1. AO2, what you're going to do, you split the simulation so into your queue, your doctors, your scenarios, your patients, all that stuff, and then you'd replace those elements. So for that'll be AO1, but if I just say, you know, you'd use that to working out the parts, so the queue, the patient's problems, the doctors, that kind of thing. You split them into different bits, and then your necessary bits. So like potentially graphics could be a thing here. So I mean, there's like, you're not going to say, all right, this is a 10-inch blade and this is a 14-inch blade. It's just a blade. Right, generic person. There's no gender on there, and this obviously that's required. There's, you know, you're not going to put, oh, he's got a mole on his face. Oh, he's got a different colour hair. Just make it really simplified. And then what would be the point of that? Why would you use these bits? Well, you can split up the abstracted parts and the decomposed parts to different individual people. You can create functions, create new modules. You can use pre-existing ones. You'll be able to give a module to each person, so you can program it quicker. That kind of thing. I can't really think of anything else. Hopefully that's okay. We've got caching. Obviously, we've not had very many things. So caching is just when you store it for future. So in this one, so what you might cache is, I don't know, that patient. That patient's details might get put into RAM. So when we cache it, you store it in the cache, but you can also see it stored in the RAM, in case you need it again soon. So it might be you switch out to a different patient and you want to get back to the previous patient. You just load the class up or whatever. And some examples there. It's saying what is meant by time complexity. So that's how quick the algorithm works, depending on its size. So there, ON, that is linear. So if you've got 10 things, it might take 10 seconds. You've got 20, it takes 20. If you've got 1, that would be obviously your it always works the same speed. And then you've got your logarithmic and all that stuff. I don't think I've ever seen that one before in my life. It's not on the list, so we'll ignore that one. But they hadn't asked you what anyway in this one. Could ask you what that one. Name a space for each space complexity. Well, it's just what? It tells you it's logarithmic. So B is logarithmic, and then because it increases with its size, it's exponential. It just seems weird, but that gives you the answer there. That's weird. Whatever. Which one would you suggest? A or B? Well, A is pretty slow. That's like linear search. That's like binary search. So it's probably better. But they want you to do some maths for that one. One sec, let me just check my phone. Sorry. Sorry, I'm on the clock because my wife's coming home soon from work. Sorry. So I'll try and speed it up. We've got quite a lot, so are we all alright so far? Obviously, type any questions, or if there's anything, like I will just go through this. I'm just going to go for a wee in a second. If you just want to, I'll tell you what, we'll have a little tiny teeny break. I didn't mean to press caps lock halfway through. Just read that message. It'll be 2 seconds. Well, it'll be 2 seconds, that's a lie. I'll be like a minute. I'm just going to go for a toilet real quick. And I'm back. You haven't written anything, so I'll ignore you all. Cool. Right. Dex's team's using an IDE. That's VS Code or Visual Studio. Whatever. So what would you use a breakpoint for? So that is a point where your program stops running. When it stops running, you can check variables and use it for testing. Stepping is when you press F11. So in that, it will stop, pause, like breakpoint, and then you can just make it run each individual line as you go along, which is obviously really good. Yeah. One sec, let's try it one more time. See if I can show you this. Right, so fingers crossed this works. One sec. Go where? Go where? Right, so here I've got a really terrible little P5 game that doesn't do anything, right? So if I just grab this here and put a breakpoint, like, trying to think of the way to do it to not mess things up. So I'll just do it here and say, I don't know, let name equals Reese. Name equals Jeff. Alert. Name. And you can't see that. So I'll just roll that up. So I'll just put some really daft bit of code there. Now if I run this now with a debugger, just get rid of this, get rid of that. So if I then run, start debugging, and use Chrome, and then if I run this now with a debugger, just get rid of this, get rid of that. So if I then run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debugging, and use Chrome, and then if I run, start debu and then start debugging. Oh, I don't want you. Go away. Why are you doing it? I ain't used this in so long. Do I have to put the bloody port on there? I forgot how you do it. Then if I don't do it, but anyway, I put a breakpoint on there. I think that's what I do have to actually. I have to configure the live server data to be port 5500, but I don't know where it says it there. I'm not using .NET though. You'll know this, James. I've forgotten how you debugging VS Code because I haven't done it in ages. But I think I've ruined it by adding that C# program. Let's just YOLO this. Bye. And then shut up. Run. Start debugging. There we go. Sorted. That's what I wanted. I think that C# program ruined it. Right. So this, I know it's really bad, but get rid of that. So you can see here, my program has stopped. Because here, you see, I can go look at name's a string. Brilliant. If I press F11, what you'll see is it's jumped from line 11 to line 12. I can then mouse over this and go, look, it's Reese. It says it here as well, if you can see that. So I can see it as Reese. I can then press F11 again, go to the next line, and name is now Jeff. So that's what stepping is. And then obviously I can then press F11, and then hopefully it says Jeff there. Done. Right? So your breakpoint pauses the program at a certain point, so you can test it. And then stepping, you can run it line by line, and you can look at every single bit of variables that change. All right, that's that. I'm not going to bubble sort. That is where you look at this one to that one. S comes after R, so you swap them, and you just show that. I don't think I need to do that. Draw it as a table. It would make sense. So this one, yeah, no wonder you asked this one, Tom. It's bloody hard. So I'll make use of a function contains that compares two strings and checks if the second string contains the first string. So again, this is another question, so you break it down. All right. So I think what you're going to do is you're not going to have replit, you're not going to have anything to solve it. But we know what it's going to be called, so we can start from there. So we start off real nice and easy. Just bear with me, I'm just going to check you can see this alright. Alright, so I can't go past there. Okay. Right. Don't worry about this end function thing, it's just so I know how big my screen can be, because I've zoomed in. So first is first, nice and easy. You're going to get a mark for this. Make a new function. So it's called contains, function, contains, and then string 1, string 2. Okay? Obviously I don't need to put it in function, I can just do that. It's okay. It says use pseudocode. You don't have to use pseudocode. You're not asked to write. You can use JavaScript. It's okay. Just be careful with various bits. But as long as it makes sense, we're okay. So quite hard, really. I'm struggling just looking at this to think about what I would do. So so I'm going to have to go through. I've got the string, so I've got fox. So if we're just going to pretend we've got fox and fox hound. So So we'll see if that word is in there. So we've got to think what we're doing in real life. So we'd probably, I think I'd probably be looking like if it's got the same starting letter and then for loop through is probably what I would think. But let's break it down. So we're going to need to have something like it's a function, so it needs to return something. So you don't do this in JavaScript, but in like other languages, a function needs to return a data type, and usually you'd say, instead of just saying function, you'd say it's a string function or it's an int function, and that determines what you're going to return. So we're going to return something. So again, this is something you have to do, it's a function, so we're going to return something. So let's say word inside. Okay, so we can say let word inside equals false, and then return word inside. So that is our first 2 bits. Then what I'm going to have to do is, I'm definitely going to use a loop. There's no reason why I wouldn't have a loop. So I'm definitely going to loop through something. Okay. We know how big it's going to be, so we know it's going to be a for loop. So for let I equal 0, I is less than. Now we're going to be having to loop through. We are going to have to loop through the first and the second word. So I think I'm going to go through the second one. I mean, what's hard is that there's probably a regex that does this already. I'm trying to remember what it is. There is actually a. I don't think you'd be able to use it, but there is a. There's a built-in function that I think it just includes. I'm pretty sure it includes. One sec. I'm certain this includes. Yeah. I mean, it's a string thing, so you're definitely going to use substring. Which I think the best way to do it. I'm trying to remember what it is. Let's do 1 second. I'm just going to try something on my replit. Console.log contains fox and then fox hound if str2 dot contains str1. Cool. It's not contains. What is it? It's something, obviously. Oh, I'm just an idiot. One sec. I am actually doing something, I'm not just studying being an idiot. I'm sure contains is a function. Oh, it's irrelevant anyway. I don't know why. Includes. That's what it is. Just Google it. It includes. Not contains. Includes. Yeah. I'll show you what it is. It's so easy in JavaScript. It's really frustrating actually, because you could just use includes. I just don't think. I mean, it's it. Right. So look at the mark scheme, right? So correct function done. Use of a flag done. Looping through string 2 done. 3 marks. Using string manipulators to check each letter, to check either letters or substrings of string 2. Correctly setting return value to true, returning true. Comments that explain the program works. It says comments, but I mean, I'm trying to think how you do it without using, because you can literally just do. You wouldn't even need a for loop. You could literally just do in JavaScript. You can do this. Return a string 1 dot includes. You could just do this, like in JavaScript. So I'm trying to think how you do it without it, because that line will actually do it. You do the whole thing. You wouldn't need any of this crap. You could just do that, or let word inside equals string in 2 dot includes, and you do it that way. It's fine. But what you'd probably have to do, I'm trying to think without using substring, because substring kind of sucks. Because I think what you'd do is you'd get let number of chars, so number of characters equals str1.length is what I presume you'd do. You're going to go through each letter, and then what you'd do is you'd substring. So you can say if substring I, comma, and then you do number of chars. This is how I'd do it if I wasn't using includes. So basically it looks at the first letter, and then however long your first string is, it takes the next 3. So for Fox, it takes the next 3. So if that equals str1, then you flag. So you say word inside equals true. I think that's all you do. Let me just bang this into Replito. This is without using that. Yeah, I think that would work. It's a little bit different in JavaScript using so substring is a function you're expected to know from GCSE, which basically you put the string and how many characters you want to take out. So if I did Reese, comma 1, it'd take out R. In JavaScript you'd have to do str2.substring. Yeah, it works. So I've just done it in Replit. And the only change I've done is str2.substring, and that works for Fox and Foxhound. Let's just try Reese, and Reese is the best. Didn't like that. Interesting. But that's correct. Replit's been a bit funny, but that's definitely correct. That's what I would do anyway. So basically, you're gonna go through the function. You go into I just realised I scrolled down. Sorry. Let me just get rid of these spaces. But I'm looping through every single letter of substring 2 and then saying, right, I'm on R, let's say, if it was Reese, and then however long that thingy is, the string is. Does that make sense? I'm just going to do something for me. It did work. I just checked. I just did it on Replit. I don't know if you'll be able to see it very well. I'll also show you. I just put it for Replit just to check. Just I had to JavaScript it a little bit. If that makes any sense, I had to make it a bit more JavaScripty for you. There we go. So I've done it for Reese and Best Reese. You can't see anything there. Yeah, so because like I say, the only difference is I had to put str to dot substring because it's slightly different in JavaScript, and I just had to make sure I did length plus 1 or less than or equal to, and you'll see like how the code works. No, what? I was hoping I could get the console up better so you can see it because I've messed up, but one sec. We'll see that here. Can you see that there? So it started off with went through the best part, couldn't find it, so it substringed to the length, so RHYS, 4 letters, couldn't get anything, and then started on the next word, RHY, RHYS. Oh, it's found Reese, true, so that worked. So that's obviously we're using substring without using includes. With what's more annoying is that you could just do console.log Reese best Reese dot includes Reese, and I'm pretty sure it just says true twice, so that whole thing is contains, but that's programming. Sometimes you've got to make your own functions and that. It's annoying, but it is what it is. So that's 4B. Anyway, that took a very long time, and that's probably where you're going to go wrong. That's one of the ones where I would make the function. So the question is, it's quite hard, right? Make the function, do the function, do the return, create the flag if it requires it, then leave it. Go back, finish the paper, and then go back to the start. It's not the start, sorry. Go back to this question, have a go at the end. You're better off picking up 3 marks than picking up no marks. I mean, it took me a while. Like I said, I'm not perfect, and that took me a while to do. I figured it out, but it is annoying. That's why, like, being an actual programmer, and that it makes it hard with these kind of exams. It's like, you just wouldn't do it, but it's what it is. I'm on the clock now, so it's best to be quick. Oh, nuts. Right. So. Right, we'll skip. Unless, do you think. Did you put that down? We did 4B, didn't we? Right. We've done this one before. We are doing that one. It's crazy long. So I think because we're struggling for time, aren't we? Done a big question, right? Okay. Get a bit of paper out. Do whatever you would normally get. Difference between passing by value and passing by reference, and what would you use for current player, which is something current player. So the parameter there. So you pass it in, and it does your it does the board game thing. So just because I used to just go put T on. Oh, it was long. It will take 2 seconds. So we'll aim to stop at 8 o'clock. But value by reference. What would you put down? And then I'll obviously go over that in a second. Right, sorry, I'm back. The perks of having to cook your own tea, which I was a student and got my parents to do it for me. Right, so I've got like 10 minutes to go. So what question are we on? Five. II. Right. So we should know anyway that I forgot where I put my bloody thing. Oh, I can do that guy. So value, reference. So reference is a pointer. A pointer. Clearly, I've got something on my mind. To the original. Value creates a copy of the variable for the function. For the procedure. Yeah. So obviously AO1 is you literally just talking about what these do. So any changes are local to the function and won't affect. Is it affect? Affects the original. Changes will affect the original. So that's your AO1. That there's nothing else to talk about there. That's it. All right. So the next one is why would we use it? So I think you'd be saying you would use by value if you're not changing anything about the player. So it might be, I'd put like an example, like checking a valid move. Do you know, let's say like it's like a chessboard, and like when you click the player, it says you can go left or right, but you can't go up. You wouldn't actually want to. You'd want to test it by saying, "Can you go there?" You know, but you wouldn't necessarily do it. And you would use reference if you want to actually update. So that'd be actual, actual movement, like damage or whatever in the game. So that'd be your evaluation at that point. So your not evaluation, application. Then you need to evaluate what's like why would you do it? So what's like why would you use by reference or by value? There's a bunch of different things. By value takes up more memory because it's actually creating. Let's create a copy of a variable, so it's going to take up more room, so it might not be appropriate. By ref doesn't do that. It'll depend as well on the actual variable. Global you would use by ref. If it's local, there's no point really. If the original variable needs to change, i.e. I'm just saying as an example there, movement, then ref. If it doesn't, then just use val. And then so as the last thing you'd be thinking about like an issue with by val, because by value isn't changing anything. The code may act differently due to inconsistencies. Now what I mean by that is, let's say it's like a card game, like Hearthstone or something. and you call this function. It's doing everything by val, and you know have like a damage multiplier or something. Obviously, it's nothing to do with this game, or like it's like a damage multiplier, or like it gives you extra health or whatever, because you've used this card on yourself in a local copy. Well, it's not actually going to apply to your actual character, so it's not going to do anything. Like, or if like you was doing current player .score, but you passed it by value, and you play a card and you get some score, it's not going to actually affect your actual score. So it's not going to make sense. So your code's going to be inconsistent because in the variable your score's been applied, but in the actual main program it hasn't. So I think that's what you're talking about for that one there. Is that all right? Right, this Bills, whoever Bills is, you've asked about pipelining for paper 2. So I know what your question is, but you're on about the builder question. So they're talking about pipelining as like not pipelining the CPU. So in paper 2, they're not talking about necessarily. Well, no, that's not true. Unless they are talking about a processor, right? Unless they talk about a processor, they are not talking about pipeline that we've done. So the one question talks about a person called Amy. Amy's processor uses pipelining. It's got fetch, decode, execute, identify the stages. You've done this question before. And you say, right, well, pipeline 1 would fetch, pipeline 2 would then fetch, whilst pipeline 1's decoding, and so on. Right, we know that one, it's easy. You're overlapping the CPU. If it's talking about like decomposition and pipelining, it's not necessarily talking about it's not talking about the same thing. Okay, so it might be that in this, I'm trying to think of like a good way of talking about it. So you've got so you're on about where it says like you don't start a function until the previous function is finished. So let's say you've got like a game where you can run around and you might run into like a wall. So this is my wall, right? Now, if you're in sort of like a sort of not a game where you can just walk into it and bump into a wall, but you can run up to it, and then I don't know, maybe you're there's a game actually called Duke Nukem, which is probably slightly inappropriate, but that one you could like touch the walls and like you like essentially you punch them and you can like get like secret doors and stuff. So it might be some sort of like text-based adventure game where you're in a room, or like a really simple like point and click game where you might need to do some validation. So you might have a function called like function player move, right? But what you might do, you might have in here is let's just say, I don't know, that's the direction you're moving in. You might have a function that's called like it could be like in chess or something, check valid move direction. Okay, so here would be the idea of pipelining. So you'd say like if that's true, then you know and let's just say player dot x plus equals direction. Let's just as an example. You don't worry about any of that stuff. So what that means is that the result from check valid move is feeding into the player move function. if that makes sense. So instead of saying, you fetch the code in execute, which is a thing, you can still get asked that if they talk about the CPU, they're talking about like decomposition and those kind of bits. They're talking about how one function's result might feed into, or the result of that function might be an input for another function. So like this one, play a move can only work if the move's valid. So it requires the output of this function for this one to work. Does that sort of make sense, Bills? I am being quiet for a second. I'm just waiting. I'm looking at the chat. I mean, he or she might have gone, so it might not matter. But that's what that's talking about. Like another example of that question as well is talking about like building a house. So like you're not going to put the roof on until the walls are built. So that's like an idea of pipelining as well. Like you can start doing bits at the same time. So you can put the electrics in whilst putting the pipes in, but you can't put the floor in until the foundations are set and that kind of thing. So hopefully we get an answer from Bills. But it's 5-2 now. Is there anything else you want me to go over in the next 5 minutes? Alright, cheers Tom. Right, yeah, so in terms of before your exam, you've got your exam 1. There are no lessons as far as I'm aware tomorrow morning. So period 1 and 2, it's free. Like I'll be just marking. Look at the coursework and that. Period 3, there might be a class of year 1s, but one of the rooms will be open, whether it's my room or not. Lunch, obviously, you won't be having because you have your exam. I'll be outside the exam for around 10 to 1. So if there's anything else you wanted to bring or go over, please bring that tomorrow morning. I thought some people might have come today, but nobody did. So yeah, so please make sure that you do that if you've got any other questions. I think this paper's going to be hard because the first one was easy. So just think about that. Make sure you know your stacks, your queues. You've looked at the past papers. You've looked at the computational thinking, your concurrency, that kind of thing. Just make sure you've looked at everything. And remember, in that exam, do not panic, but make sure you actually say, right, I don't know what this function is going to do, but you can write a function header. You can write return. You can make a flag if you need to. And definitely make sure, last thing I'm going to say, when you are programming, OOP stuff, class, like that, anything private, hashtag, private thing. Those are your two private attributes. Constructor, then you say then this dot hashtag private 1 equals inpriv. This dot hashtag private 2 equals inpriv 2. Yep, that's how you would do that. That's your private and your public. If they ask you to make a getters and setters, a getter is a function. So I'll be saying function get priv1, if that's what it's called. There'll be no parameters. Return this dot hashtag private one. Setter, same thing. Python, I honestly have not done oop in Python. I can get some stuff up for the end since you're a random dude, if you like. I'll just finish this first. So if you're inheriting, so let's just say class, I'm just going to call it number 2, extends name. Right, then you might have some extra hashtags or whatever it is. You're still going to have a constructor, but what you're probably only going to do is your extra bits, right? So I don't know. That's for 2 new attributes. You need to call the super constructor. So you call super. Sorry, you need all the things. So you'd have the same as your constructor. You're overriding that constructor. You then call the super constructor with the things that the original one needs. So this one needs the imprivs, and then you do, you know, this dot hashtag. I should probably have called them better names. Equals new attrib. Okay. You don't need to worry about protected. That's how you do your inheritance if they ask you it. I can't say they're definitely going to, but if I was writing the exam, I would. That's how you do that. Okay, so your class, your private attributes, obviously public. You don't have to write public. It's fine. I'll move this up a little bit. Just can't quite see everything. Then your getters, say function. If it's a setter, I would do procedure. Procedure. Something like that. And then you call your constructor as normal. Any extra attributes can go in there. You don't have to put these ones in because they're going to get called later on. Now, in real life, this wouldn't work because you can't use a private attribute in an inherited object, in an inherited class. You have to use protected, which is an underscore, but they aren't going to ask you that. You don't need to do that. Okay. So that's that one. And then just for the fella that I don't know, I will just get a conversion for you and I'll put it in the chat for the Python. But that is just inheritance and things like that. Like, I'm hoping like your teacher has shown you how to do that. But obviously I don't know who you are, so we'll have to see. Is there anything else whilst I'm just doing this for this fella? So yeah, so yeah, that example I sent you has the how you do your constructor. You can use Python as well. The only thing I tell my students is to make sure anything that's very Python-y, like obviously self dot in Python is the same as this dot for us. Just make sure I would put a comment saying that it's in JavaScript just so they know. when you like become an assessor, you do have to say that you can program, like it's a part of the application. So yeah, so I'll put it in the chat, but I've literally just completely copied mine to ChatGPT, and this is what the equivalent of what I've done roughly would be like in Python, which I'll paste into the chat at that, if it lets me. It won't let me, so I will just, there we go. So JavaScript on the left, Python on the right. There you go. That's what the equivalent would be of my. I know I've done terrible variable names and things like that, but that's what it would be. Now back to my kids. Is there anything else you want me to go over? Because I can give you like 5 more minutes. Probably longer than I'd like. Give me a sec, Chloe. I want my tea. I just want my tea. Right, so look. I do have something in here that I can pull up really quickly. Right, hopefully you can see this okay. This is in Teams, Chloe. Fair. So when it comes on, sorry, I'm a bit snotty still. So O1 is constant, which means it always takes the same amount of time. Okay. So an equivalent of that is this a little bit too. Just give me a second. I'll just make this a little bit bigger. Okay, you should be able to see that okay now. So O1 would be the equivalent of doing something like, let's say we had an array, and get me the 5th thing. So it'd always be the same speed. Okay? So it doesn't matter what, if you've got a million things in the array or not, I'm only ever getting the 5th or 6th thing. So that would be O1. Okay, log n, and then n. Trying to get it so you can see everything, alright. Right, I've just tried to really simplify it. I don't think that's what I was looking for. So you've got this, Chloe. This is yours. This is in teams. So it goes through. So I'll leave this back on there. So your constant's fine. Log n divided by 2 is actually binary search, like you divide and conquer algorithms. On, slow, linear search. Polynomials, bubble sort, because we're going over. It's square because you always, when you start right from the beginning, so it's always going to take like essentially like 2 or 3 times as long. And then exponential, it's like the opposite of logarithmic, so it doubles. Very inefficient. Recursion's inefficient. What's that? And then going to the actual things with this cheat sheet. So you usually look at the average on the whole. You always look at the worst. Sorry. So linear search in the worst case, you've got 10 things to search through. It takes you 10 searches. Binary search, O log n, as we've said. Binary search tree, on, hashing, on. Because with hashing, you might have to do a linear search inside there, so that's the worst case scenario. And then bubble sort, best case is on, worst on squared, which is you've got to go through the array, however big it is. Like, if you got 10 things, you do it 100 times, which kind of sucks, because you've got to change every single letter or number. Insertion sort is the same. You've got to do a merge, an insertion going back for each one. Merge sort is n log m, and quick sort is on squared, because you've got to do the pivot on every single one as well. That's my quick one. Is that alright, Chloe? I will find out for you. It's in new deal tasks, but I can move it to. You know what? I'll just. I don't want to do that. One sec. I'll just download it. I'll just put it in the I've got it yet. I don't want that. I'll put it in the. Give me a sec, and I'll just put it. I'll put it into the right thing for you. Right. So what I'll do is I'll put that. It's in the root folder. So it'll be like where class materials and that is. Okay, that's that done. I've sent you it as well, Chloe. Okay. Just living, is that you, Amelia? Yeah. Right, cool. No worries, Chloe. Can't be able to call on doing that thing, but anyway, I'm getting moaned at by my wife. So what I'll do is you can choose whether or not it becomes a VOD or not, but I'll just let it be a VOD, and then you can go ahead and obviously do what you want with it, watch it tonight or what you want to do. But yeah, from 9 o'clock Well, from 8 o'clock, my room will be free. So feel free. Ah, right. Thought it was you because I just messaged you earlier. But yeah, so from 9 o'clock, well, 8 o'clock onwards tomorrow, the room's free. So I will see you all then. If you come in, please bring stuff. Don't expect me to like have something prepared for you. I mean, I was disappointed because nobody came today. But anyway, if you want to do me a favour, if you want to go back and like all my videos and add a comment to get my views up, you can do. But yeah, I will wish you all luck, all 9 of you. And I'll be in all day as well. I've got a meeting to school, so if you want to come and talk about the exam afterwards, you can do. But I'll see you then. Have a good evening. See you later.